Hello and welcome everyone to this webinar where we're going to be talking about decarbonising oil and gas production. I think it promises to be a really exciting session. We've got three excellent speakers and the subject matter I think is highly relevant today. A few bits of housekeeping before we get going. Firstly, big thanks to ERCE, who are sponsors of this programme. I'd also like to thank Alison Isherwood, who's chair of the Net Zero Committee of the SPE London section. And it's the SPE Net Zero Committee who are putting on this programme. So other bits of housekeeping, we're keeping cameras and audience muted during the session. We do want plenty of questions from the audience, so please use the chat function throughout the session. As Camille mentioned, SPE will be recording this, so request no recording or distribution by the audience. And we're hoping that all presentations will be made available via the website. The agenda, each presentation will be about 15 minutes. We'll have a bit of Q&A, hopefully about half an hour at the end of the presentation, and then we'll have some closing remarks and aim to be finished by 6:30. Okay, so in terms of the panelists, we've got people representing producers, developers, and the supply chain. And I think that's important to get that range of perspective when we're talking about decarbonising oil and gas. So we've got Pierre Girard, who's the director of new energy at Neptune. Neptune, they've got production assets both in the UK and Norway. So I think it's going to be really interesting if Pierre can bring some lessons learned from Norway and what they're doing about reducing the carbon intensity of their oil production. We've got Steve Brown, who's CEO of Orcadian Energy. They're a developer hoping to bring the pilot field into development. And I think, starting from a clean slate, what can we do with new developments to minimize carbon emissions will be key. And finally, we've got Karen Spendley, who's Technology Sustainability Advisor at Schlumbergers. At the recent Offshore Europe, many of the keynote speakers talked about the importance of the supply chain and some of the technology which the supply chain brings. So hearing from Karen there will be key. So before I hand over to the first speaker, who will be Pierre, I've just got one further introductory slide. And I wanted, just by way of setting the scene, to show oil production and demand in the UK. There are a number of demand curves out there, but the one we probably should be most focused on is shown in the green dashed line there, which is from the Committee for Climate Change Net Zero Balance Pathway. And if you look at the production forecast, which is in blue of UK domestic production, you can see that there's both a demand for oil through the next decades, but also an undersupply of domestic oil production. And this is exacerbated if you include non-fuel based petroleum in the the CCC's net balance pathway estimate. That would add approximately 6 or 7 million tonnes a year to the estimate. And it also gets worse if some of the proposed new developments, such as Cambo, don't go into development. We'll be producing less than is estimated here, so the imports will be more. And what is absolutely key with this So especially for us as oil and gas industry professionals, which I assume most of us on the call are, is that not the entirety of the supply does not have the same carbon intensity. And the carbon intensity can vary from country to country, from field to field, and even over the duration of field life. So we need to be focused on minimizing the carbon intensity of the oil which we supply. And that could mean also thinking in terms of prioritizing domestic oil, where we have some control over the emissions because we have a well-regulated regime. But it's also thinking about some of the technology which we can apply when we're doing our field developments and our day-to-day jobs to reduce the intensity of the oil and gas which we're producing. So hopefully that sets the scene. I'd like to now hand over to Pierre for his presentation. So Pierre, over to you.
Thanks very much, Barney. Can you hear me? Okay.
I can hear you fine. Are you able to try sharing your screen? I will stop sharing.
Can you see my screen?
I can see your screen. Yep, that looks great.
Very good. And let me put a better view. Here we are. Right. Perfect. Very good. Thanks very much. Good afternoon, everyone. So, like Barney said, my name is Pierre Girard, and I'm the director of new energy for Neptune Energy. And that's a role that I joined, position I joined earlier this year, essentially having spent around 30 years in the oil and gas industry previously in a number of roles, starting from the reservoir side. I guess just to say a few words on Neptune. We do have operations in UK and Norway with indeed different approaches to sort of CO2 taxation and the implications that this may have on decarbonisation. We also have operations in the Netherlands, in Germany, and then in North Africa, Algeria, Egypt, Indonesia, and Australia. So fairly diversified set of countries with different regimes in terms of CO2 taxation, and also different approach to decarbonisation. I guess what I would say just before moving on to the slides is that we really truly believe that oil and gas are going to be an integral part of the energy transition. Like Barney presented on the previous slide, essentially we really need to keep producing oil and gas for a number of years to come. And also with new developments. And importantly, I guess all of these different sources of oil and gas don't have the same carbon footprint. For example, importing LNG doesn't have the same carbon footprint as producing indigenous gas from the North Sea. So we believe that reducing the dependency on imports is also a critical factor. I guess I'll come back to decarbonisation solution, but obviously, accessing green electricity at low cost is a critical element to that. But it's not the only way to unlock decarbonisation. Having long life assets is another important element. and also having some clarity on CO2 pricing outlook. That is a critical element to actually facilitate investment decisions. I suppose the other important point is that decarbonisation is not only about electrification. And it's also also can be facilitated with carbon storage. And importantly, I guess carbon storage also means that we need to have sort of affordable and low-cost storage, which can be a critical success factor for future decarbonisation. And it's very important to create an environment where the storage providers are allowed to compete with each other, to provide value for money, and to provide solutions that are the most efficient for the taxpayer. But clearly, carbon storage is a way to extend the life of existing assets, and therefore to enable decarbonisation. Early decarbonisation of so I guess Neptune approach to new energy, announcing our low carbon position and creating. We are in a fortunate position to have a fairly low carbon intensity. So globally in our portfolio, we were at 6.3 kilograms per BOE in 2020, and that's looking at our operated position for scope 1 and scope 2 emission to the average of 7 grams per BOE. So even below here, you can see a comparison of Norway and the UK. Norway assets are purified, and that does help obviously a lot. And in the UK, we have young sort of gas producing assets, so it does also help. And like Barney said previously, obviously, especially when you switch on compression, you have a step change, a step increase in emission. If we look at this central graph, the different activities that we are undertaking to manage our emissions and meet our targets stated, which are CO2 emission intensity of 6 kilograms per BOE in 2030, and net zero in terms of. So I guess the methane is essentially, I would say, business as usual, although it's not business as usual. But and it's solving, as well as making sure that we don't have fugitive emissions. And I guess the other sort of basic building block is, as I mentioned, both and proposing both for operated asset and non-operated assets, I would say. In terms of electrification, we are in Norway, but already electrified. Essentially, it was electrified by design, and essentially, it's so the power is provided from the shore using a cable, an electric cable, and essentially it's electricity from a hydroelectric source, so should be emission-free. But you also have gas compressors, because we do export gas, and I guess there is still scope for additional reduction. We have other projects that are being executed right now or in the execution phase. One is Gudrun electrification project, and another one that for which the study is ongoing, and that's Schnobit. So all of those are essentially targeting or aiming to electrify existing power from essentially green source from the grid in Norway. And looking sort of further into the future in terms of repurposing of our assets and as well as carbon storage, we are involved in a couple of projects. One is called Poseidon, and that's a pilot hydrogen or green hydrogen production pilot, and I'll come back to it in a minute. And we see that it's a great way to repurposing our assets, and that extension of the life of the assets essentially can provide a lever to facilitate the investments required in electrification or decarbonization. So after this first step, we are aiming to essentially scale up the sort of production of green hydrogen offshore to a very different level. We're also involved in a couple of carbon storage projects, and I'll come back to these two projects in a minute. But the headline figure for R10 is essentially that we are aiming to store up to 120 to 150 million tons of CO2 in depleted gas fields, and with a specificity that we intend to keep producing gas whilst we are storing CO2. So it's a hub with a number of satellites, so that's essentially make it possible for us to continue producing gas from some of the satellites whilst injecting and storing safely CO2 in other satellites. So turning to these different key projects one by one. So why do CCS at R10? Well, it's quite sizable in terms of storage capacity, which is currently estimated at between 120 and 150 million tons of CO2. It's a very well known area in terms of subsurface, with about sort of 50 wells that have been drilled over the years. It's an area that is well connected and not too far from the shore, and so we see that as a great opportunity. And like I said, I guess one of the specificities to have this dual-purpose reconfiguration of R10. And currently, we're progressing the feasibility work, but importantly, I guess it's quite key to realize that Neptune and predecessor companies have injected CO2 in K12, which is one of the satellites of the R10 hub, for 14 years. So during 14 years, we were producing gas, off-spec gas, from one of the satellites, usually removing the CO2 before sending the gas onshore. So initially the CO2 was vented, and then the CO2 was fully re-injected into K12 Bravo field. So that's given us quite an interesting first-hand experience of handling CO2 injection in Southern North Sea and in offshore environment. If I focus for a minute on Q13 Hydrogen Pilot, essentially what we are trying to do here is to locate an electrolyzer on Q13. Q13 is normally unmanned installation that is powered from shore. So I guess once again we have a cable here that goes from the shore at the Dutch shore to this NUI, providing full electrification. And I guess so we'll locate this electrolyzer, essentially take seawater, have some initial demineralization of the seawater, and use it to generate hydrogen and oxygen. And then the hydrogen will be blended into the production and exported to the host, whereby the hydrocarbon will be separated, and then the hydrogen will follow the gas stream all the way to the shore. It's really a first step to prove that this can be done, to identify all the issues that might be associated with safe production of hydrogen in an offshore environment, what would need to be changed, what needs to be done in terms of metering, and in terms of safety and safety case, etc. We've recently been granted a subsidy from the Dutch government, and the project has been officially kicked off earlier this summer. I guess right now we are really focusing all our efforts to towards first production of hydrogen. Finally, another project that we are involved in, and you might have read about, is the Decarbonising project. This is a UK-based carbon storage project where we are sort of aiming to at least initially produce blue hydrogen from the Thenothrop site, where the TGT Thenothrop gas terminal used to be, and the blue hydrogen obviously will be associated with CO2 capture, and the CO2 is planned to be piped, repurposing the disused CMS pipeline towards some forward deep closure in the Bunter formation, where you have saline aquifer. So quite excited about this project, and I think, like I said before, it's quite important for the energy transition to facilitate low-cost transportation and storage of CO2, and to have a varied array of decarbonisation opportunities. I guess in the program here, a number of information around sort of what we are doing, our experience in CO2 injection in the Dutch sector, the fact that with Poseidon we are aiming to be the first offshore green hydrogen plant in an oil and gas environment, and some of the other sort of key features. So just to conclude, I guess the key points. Neptune does believe that oil and gas is going to be required for the next 20-30 years, there's no doubt about it, and that in this journey towards net zero, there will be a requirement for new developments. And I guess importantly that these new developments will ease the pressure on new ports, because we believe that that's the best way from a carbon footprint to produce oil and gas is really to rely on locally produced hydrocarbon. Decarbonisation, I guess, can be facilitated by having access to green electricity, which obviously is the case in Norway. It does also help, or is critical to have a long life ahead of the asset, so that you can amortize the cost over a longer period of time. And finally, I guess having clarity on CO2 pricing or CO2 taxes is extremely important. So you'll be aware that in Norway, the Norwegian government has made a recent announcement on their CO2 tax outlook, essentially rising to current value to over 200 euros per ton. And that clearly sends a strong signal to the industry and also makes the economics of electrification or decarbonization much more attractive. I guess importantly, we also need to decarbonize using carbon storage, and having a competitive landscape is also very important. And also importantly, it's critical to avoid monopolistic positions to reduce the cost to society, which essentially is the holy grail in terms of decarbonization, is doing it at the lowest possible cost. And finally, I guess we believe that there are a number of opportunities for repurposing or dual purposing our oil and gas facilities, either for CCS or for offshore green hydrogen. And these life extensions will and should facilitate the decarbonization investments, which concludes my presentation. Thank you very much.
That's great. Thanks, Pierre. That's really good. We're running a little bit behind time, so I will, we won't take any questions now, but I really encourage everyone to get in that Zoom chat function and post your questions to Pierre or any of the other panelists. I've already seen we've got some coming in. So I will now ask Steve Brown for his presentation. Thanks, Pierre, and over to you, Steve.
Very good, Barney. With a little bit of luck, you should be able to see a screen with a beautiful sunset, a spare chat window, and a jack-up rig.
Not at the moment, Steve. We are seeing something with various contacts on there.
Oh, right.
Camille, are you able to provide any advice on this?
Right.
Hi, Steve. So we are currently seeing your entire desktop. So what you want to do is share just the particular screen for your slides.
Right. Let me just.
But we honestly did check all this beforehand.
There we go. I think it's working now. Is that better?
So it's, yes, it is.
Right. Very good. Okay. So apologies for that. Let me skip back a couple of slides, show you the sunset. I don't want you to miss that. I'm CEO of Orcadian Energy, and really what I'm going to talk about here is how we as Orcadian, a very small company looking to develop the pilot field, responded to a challenge thrown out to us by the Oil and Gas Authority to significantly reduce emissions from our development scheme. So, first of all, a little bit about the pilot field. It was discovered in 1989. It's in the central North Sea, about 150 kilometers due east of Aberdeen. It's really well appraised. The basic characteristic of the field is it's got great rocks. It's 34% porosity, 95% net to gross, 2 to 10 Darcy's, a load of oil, 160 million barrels. What's the problem, you're thinking? Well, the reason the field, south of the field, it's around about 160 centipoise, in the north around about 1200 centipoise, and that's what held back development for many years. But we've put together a polymer flood plan that actually recovers 79 million barrels from this field. That's 2P reserves, and that's based on a low salinity polymer flood. So let me just show you what our development scheme looks like now. This is part of our response to the OGA. We're going to develop the field using an FPSO for most of the processing and actually power generation duties. We'll have a couple of wellhead platforms, each with 20 slots. We'll have a lot of wells. It's a very well-intensive approach we've taken. So there's 34 wells in this development scheme. They're spaced 100 to 150 meters apart. We'll actually have 2 wellhead platforms drilled from a jackup, and we will have a floating wind turbine to provide some of the power. So that's actually part of the solution that we proposed to the OGA just in July. So this slide here really summarizes the whole story on CO2 emissions per barrel to be produced from pilot. Let's start with a couple of benchmarks. So the first is, what is a typical viscous oil? What are the emissions associated with a typical viscous oil? And if you just take the Kraken and Mariner environments and divide the CO2 emissions number of barrels produced, you get around about 30 kilograms of CO2 per barrel. If you were to do a steam flood, you'd be up at 90 kilograms of CO2 per barrel. And actually, we did think we would like to do a steam flood and pilot. Turned out we actually made more money with Polymer, so it was a pretty easy decision to switch to Polymer. And that 30 also compares to the North Sea average in 2018, which was 21 kilograms of CO2 per barrel. If we just decided to do a water flood and pilot, it would have been about 25 kilograms of CO2 per barrel produced. Adopting Polymer flood shortens the field life, reduces fluid handling, reduces energy consumption, and compared to a typical viscous oil field, we've halved emissions with emissions of 14.4 kilograms per barrel. That was what we submitted to the Oil and Gas Authority in September 2020. And I have to say, we thought we did a pretty good job. You know, we'd reduced emissions compared to the North Sea average, but we were told, really, you've got to do better. What can you possibly do that's going to improve these emissions? And we want to look really hard at electrification. So we went away with our engineers. We used Orcadian Energy to support us in this project. And we looked really hard at what you could do both to the process and the power generation systems to reduce emissions. And by incorporating heat pumps and reciprocating gas engines, which are much more efficient than simple cycle gas turbines, we get down to just under 6 kilograms per barrel. So we've halved it once, we halved it again, and then incorporating a floating wind turbine in the development scheme, we halved it again. So we're down at 2.6 kilograms of CO2 per barrel, and that compares very favorably with the option of actually powering from shore, which would have been about 2.7 kilograms per barrel. And we think we've got a really good benchmark project. So let me take you through all that in a little bit more detail. And right at the end, question, probably, which is, that's great, but what did it cost you? So let's just focus in on how polymer flooding reduces CO2 emissions. So I have a couple of production profiles here. Oil's in green, water's in blue, and the top one is a polymer flood, the bottom one is a water flood. I've got a couple of little core slabs as well. These are core slabs with 2,000 centipoise oil in them. And in the bottom one, it's being water flooded. That's after 2.7 pore volumes of water have been put through. And what you see is the water's just fingering through the oil. It's just fingering through the oil. It leaves most of it behind. And that's why with a water flood, you've got very high fluid handling requirements and your field life is very long. Look at the polymer flood. What happens when you viscosify the water and you put polymer into the water is you start to stabilize that flood front and you get a piston-like displacement of the oil out of the reservoir. And you can see that happening in the production profile there for the polymer flood. You get faster, higher oil production, and you've got much less fluid to handle, just 100,000 barrels a day fluid handling required for the polymer flood versus 250,000 barrels a day for the water flood. And I've actually taken those profiles and I've plotted them in a slightly different way. I've plotted the water injected versus the oil recovered. And the blue line is how a water flood goes, and the green line is how a polymer flood goes. So you shorten the field life, you reduce the fluid handling requirements, you're using much less energy. That's the key driver of CO2 emissions. And in this world today, I'd say if you're developing a viscous oil field and you're not using polymer, right from the start, to get these benefits, you have to do it right from the start. You don't do it as a tertiary polymer flood. That's old hat. This is the way to do it. And if you're not doing a polymer flood in a viscous oil field, you're not doing it right. So how did we get our emissions down further? Well, this set of charts explains how we calculated our emissions. I say we, what I actually mean is Crondall Energy and a very bright electrical engineer there called Joel Maisie, who did all this work for us. First of all, we quantified the power demand. So this is, the blue is for the FPSO, the pink is an assumption that we would electrify the jack-up rig and run that from our own electrical supplies. And the dark and light greens are the power required for the downhole pumps, and the red is actually the export pump. So this is the total power demand. It's knocking in 18 megawatts of power demand over the life of field. It's quite a short life, 11 years. And that translates into 8.53 kilograms of CO2 per barrel to generate all that electricity. To that, we then had to add some process heat because the separation system in this version of our development plan was electrostatics with very high process heat demands. And those two things together add up and made the 14.4 kilograms of CO2 per barrel. We also keep track of those scope 3 emissions. So there's emissions for the supply boats, there's emissions for transporting the oil from the field to the refinery. But actually, we haven't started to address those. We've really just focused in on our scope 1 and scope 2 emissions, which in this case are 14.4 kilograms per barrel. So that was our base case. That's where the OGA said, go and do something better. And here's a couple of examples of what we've done that's better. We looked at our process heat demands. And one of the things we did is we adopted wash tank technology for oil separation. That's a lower temperature process. So that actually reduced the process heat demands. But we also put in a heat pump. Now you hear a lot about heat pumps in the press, and they say, you know, you've got to spend 10 grand to put a heat pump in your garden. Well, we're spending $5 million to put an industrial heat pump into our process, and it really makes a positive difference. The next thing we did was we looked at our power generation systems. And if you look at a simple cycle gas turbine, which is this from here, you're talking about something that's in the low 30% efficiency. Combined cycle gas turbines have been designed to go offshore. They can get up towards 45, 46% efficiency, but they're big and complex. What we've gone for are actually reciprocating gas engines, basically just big diesels, but tuned to run on gas and to have a smart heat recovery system. Those are almost 50% efficient. You put those two things together, and we actually went away and focused on some of the power demand requirements on the downhole pumps as well. And we've introduced this demand for the heat pumps, and we've got our power demands down to 15 megawatts, which is just under 5 kilograms of CO2 per barrel, adds up to just under 6 kilograms in total. So that have the emissions again. And then we looked to work with a company called Floating Power Plant, who have a design for a floating wind and wave power generating system. We're aiming to use a 12 megawatt wind turbine and 2 megawatts of wave power. And we add that into the process. What you notice is actually our power demand goes up a bit because we have more heat pumps, because we have less waste heat, but our emissions are down to 2.6 kilograms of CO2 per barrel. And this is actually a very significant reduction compared to other oil developments, and especially heavy oil developments. So we thought it would be useful to put our development in a global context. And I apologize, I'm about to switch units. So I'm about to go from kilograms of CO2 per barrel of oil equivalent to grams of CO2 per megajoule. And the reason we switch units is because we have a paper to compare ourselves against. This is a paper published in Science in 2018 by Masnadi et al. It's a very big group of authors, but the core were based at Stanford University. They developed a tool to estimate emissions from oil and gas development projects and built up a data set which covered 80 million barrels of global oil production. So roughly 80% of today's global oil supply. And what they show on this chart is scope 1, scope 2, and scope 3 emissions up to the refinery gate. They're obviously not counting scope 3 emissions which occur when the product is consumed, but they're taking it all the way up to the refinery gate. We redid our calculations to include all those things. We end up at 1.4 grams of CO2 equivalent per megajoule, incorporating that single wind turbine. And that puts us at the low end of the lowest 5% of global oil production. But it's even more impressive. I'm saying it's impressive. Maybe it's up to you to make your mind up, but I think it's kind of impressive. Whenever you compare it to other viscous oil fields. So these red and orange fields are all the viscous oil fields. And typically that viscous oil emits about 10 times as much that will be emitted on the pilot development. And we look at this and we say to people, we should be producing our own oil and gas. We should be producing oil and gas here in the UK. The OGA's actually a very effective regulator. They've laid out a challenge to the industry. The industry's responded to it, and we're able to produce our oil with a much, much lower CO2 emissions profile than anyone else in the world. And all that would happen if pilot was stopped from being developed is that we'd import some of this stuff here and more of this stuff would be produced to meet UK demand. So that's where we sit in this. We think we've done a great job here. It's much, much easier, I've got to say this, to do this when your development is on paper. It's much, much harder to take the CO2 out of a producing oil field, but that's what we've been able to do. So I'm done, Barney.
Steve, that was excellent. Thank you very much. Yeah, I mean, it's really fascinating to see what can be done if you're starting from a blank sheet of paper with a new development, as opposed to doing modifications to existing developments. So I think there'll be lots of questions. I know I've got a few. Keep the questions coming in, everyone. But just like to say thanks again, Steve. And I'd like to hand over to Karen for her presentation. So over to you, Karen.
Thanks, Barney. Am I allowed more than 3 minutes?
Yes, crack on.
That's all right. Those are amazing presentations to follow. Let me play IT roulette. All right. Is that working?
Yes, that looks good.
Perfect, thank you. Yeah, no, so amazing to see the momentum from Pierre and Steve there. And yeah, I've got a slightly different perspective coming from oilfield services, if you like, and the role of technology in decarbonising oil and gas. So I've got a bit of background context, if you like, the perspective that we see, and then on to technology and how we're quantifying the benefits that certain technologies can bring over others to address, you know, some of the challenges that have been mentioned. So I'm going to go through this background quite quickly because I think probably this audience is already familiar, but if we look at sort of global estimated greenhouse gas emissions to be around 55 gigatons of CO2 equivalent annually, and around 70% of that being absorbed by natural sinks, and that 30% is what's causing the global warming estimated to be around 2 degrees over the next 20 years or so. and the predominance of that being CO2 in the atmosphere, but also methane. And I mentioned methane because we're going to go back and talk about that in a little bit more detail in a minute, if you like. And the sources of those come from across different industries. So around a quarter from heating and energy requirements, again, around a quarter from agriculture, 27% from different industries, 14% from transportation. And I'm going to pause at this 10%, which is the extractive and mining industry. So this is where oil and gas sits. And that 10% is really interesting because this is the industry itself. It's not the consumption of fossil fuels, but the industry and the activities that we do. Which means that then if we look at the source of those greenhouse gas emissions, around 70% is from fossil fuels and an estimated 42% from oil and gas in itself. So the impact of oil and gas from that 42% and then the 10% of the industry itself can't be underplayed. And this is what we're looking at as far as decarbonisation and the importance of decarbonisation. Within the context of the challenge of rapid decarbonisation and a reduction in greenhouse gas emissions of around 40% by 2030, and also a massive estimated growth in the world economy that's going to drive an energy demand. So this, if you like, is the context of what we're looking at as a problem, as I'm sure you know. Now, Steve threw around the concepts of scope 1, 2, and 3. So I've got a little slide to sort of show what those are and why they're important and the context that they sit in for anyone that's not familiar. So scope 1 are called direct emissions, and they follow you around, if you like. So they are the emissions associated to running your facility, as we mentioned, sort of rigs and production facilities, and any methane emissions, vented or fugitive, that occur at your facility are included in scope 1. Scope 2, the indirect, this is the electricity, the power that you buy that's generated somewhere else and transported in. Scope 3 is where it gets really interesting because they are emissions that are associated or a consequence of the activities that you do, but don't sit within your own value chain. And so here, upstream, we can see, for example, purchased goods and services. And then downstream, we can see the use of sold products, for example. Now, this is important for both sort of producers and for suppliers like ourselves to understand that entire value chain and where the emissions are coming from. And if we look at the industry itself, and that 42%, which translates to around 23 gigatons, you can see the bulk is the consumption, the use of the sold product, so the burning of that fossil fuel. But there's also this quite a significant part, which is the industry itself in scope 1 and scope 2. Now, Schlumberger has taken a look at its scope 1, 2, and 3, and you can see we are a scope 3 company. Where we see that in the inventory that we've done, a very large component in that purchase materials, purchase goods, inputting it into our activities, and then the use of our technology by our customers. And so if we're to look at decarbonising oil and gas, we can't ignore, for us, those scope 3. So how do we split out the industry emissions? So we take out the usage of fossil fuels and we go back to that around 5 gigatons of the industry. As you can see, more than half is coming from methane, and the importance of methane, both vented and fugitive, on greenhouse gas emissions. And this is because of what's called the global warming potential of methane. It's around 84 times that of CO2 over a 20-year period. And we can see that both in upstream and downstream. Then you can see, as was mentioned earlier, the importance of heat and power to production facilities and extraction and drilling. And then we see the importance of flaring and of transportation. So if we look at this, what it says is there are opportunities across the entire E&P cycle. We'll need multiple solutions of varying different scales in order to be able to address all of the emissions involved in the industry. Globally, we see a massive increase in terms of the emissions covered by country pledges. both written into law, but also proposed and in policy documents. But we know that greenhouse gas emissions are also increasing. And so the gap needs to close, and it needs to close by the actions that we take in the decarbonising of the industry. As far as pledges towards reducing scope 1, 2, and 3, as you can see here, different industries are at different levels as far as company pledges and alignment to the Science-Based Target Initiative and meeting the Paris Agreement. Oil and gas is somewhat lagging as far as committing to the Paris Accord and pledges and commitments. But we expect that to accelerate as we see the gap between policy and the social pressure for decarbonising energy. We expect that to increase. Now, I'm going to take a little bit of a detour here and some slides that I pilfered from IPECA. But this sits within, we talk a lot about carbon, but it sits within a broader context of the United Nations Sustainable Development Goals, which cover social, environmental, and economic development for the world. And IPECA, a couple of years ago, I think it was 2017, put together what they call the Atlas, where they looked at the UN SDGs, all 17 of them, and how the industry could impact them. Now, it was a map, it was an alignment, but it didn't give much detail. But earlier this year, they launched the roadmap, which takes the 3 themes of climate, nature, and people, prioritizes 10 of the UN SDGs, and then adds on the partnership. Because as we know, we're looking across entire value chains. No one person owns the entire cradle to grave, if you like. And it sits across 8 impact areas. So these have actions for both IPECA and oil and gas companies in accelerating progress towards the UN SDGs. And so Schlumbergers Strategy is based in those UN SDGs, sits around across the environmental, social, and corporate. I'm not going to go into much detail on the social and corporate because we're here today to talk about net zero, but our 3 areas of interest, if you like, around environmental sustainability and addressing climate change in particular, are to reduce emissions in operations, in our own operations, our scope 1 and scope 2. But also to deliver technology to lower our customers' emissions. So what can we do within the industry? How can our technology play a role? And accelerating innovation in low carbon energy. So what are the alternatives going forwards? So I'm going to talk next only around that middle section, so delivering technology to customers to lower their emissions. So we looked at the 6 environmental UN SDGs. And they cover water, they cover energy, life and land, life underwater, responsible consumption, and climate action. But those are all quite hard from a technology perspective to calculate and to quantify. So we wrote 8 attributes that map to them, but they're much more specific for our engineers to be able to write a quantification around. And the top 4, as you can see, talk about this topic of emissions reduction, energy reduction, electrification, and also the component of digital around surveillance and assessment in order to be able to manage emissions. The other 4 are impactful for biodiversity, for example, so hazardous material reduction and cleaner chemistry, our water stewardship, waste management, and also a physical or a size impact of the sites that we operate on. And these technologies within oil and gas, we're calling transition technologies, just as a name. So if I use that term, that's what I'm referring to. Now, what we wanted to be able to do was to describe technologies and show the benefit that they would bring. And that required us to quantify. But in order to be able to understand the data needed, the standards that we needed to align to, we started with commercial technologies. So once that we had more data on, we understood the operational scenarios, we understood the manufacturing of them, supply, etc. So we started with more than 100 technologies that were already commercial. We looked at those 8 attributes and how each technology could deliver a reduced impact, but then put together a method or a framework for doing those quantifications across all of the different technologies that we have, from chemistry, from surface pumps to downhole tools to compressors, just everything that we have. We put that framework together, and I'm going to talk through that in a minute. And as we go through now these quantifications and we qualify them, this is what we're starting to now show to the industry and show those numbers and the quantifications that we've done. So it's a complex arena. There are many standards, from the Greenhouse Gas Protocol, the ISO 14000 series, all of the information around greenhouse gases from the IPCC, energy emissions from the IEA, many databases and companies providing information on materials, embodied carbon, energy emissions depending on the country that you're in and the source of that energy, and all different types of transport emissions, from supply vessels to airplanes to helicopters, you name it, from DEFRA, EPA and more. So there's a lot of data and a lot of standards. And this is also a topic that's quite new to many people. So we needed to put together a framework that could describe the arena, describe how to quantify these emissions in a complex environment, but at the same time make sure that it was robust and consistent across all the types of technologies that we have. Now, on the right-hand side, I've got a graphic that comes straight out of the Greenhouse Gas Protocol product standard, where you can start to see we're looking at the life of a technology across from that initial sort of purchase materials, as I mentioned earlier, all the way through the facility that it might be manufactured in and production, onto distribution and usage, and so the downstream angle, if you like. Now, each technology will have a slightly different life map, if you like, and the different phases will also be different based on the type of technology that it is. So our framework starts with understanding the scope. What is the technology that we are looking at, and how does it sit within an operational process? And so we define that scope and define the boundary of the comparison and the quantification that we want to make, and what the reference technology or the reference process would be. We then look at the proposition. How does that technology provide a benefit? And are we looking at energy or emissions or water? And we see that technology tends to sit in one of three areas. It can have a direct efficiency, if you like. So, one motor or one engine can operate in exactly the same facility, but with a higher efficiency. We can look at an indirect, which often is a system-based quantification. So by switching out one technology for another, do I drive a wider system efficiency or a system energy consumption? And then the third one is elimination. Am I changing a process? Am I changing the way that I do an activity? So I'm eliminating parts of those processes or activities themselves. We then map the life cycle to identify those major contributors through a screening. And so the example in the middle here, we might see a raw material component, and we might see an in-use for customer component. And then we'll start digging in deeper. We gather data, whether they be operational, whether they be measurements, maybe there'll be external references, and sometimes a proxy, depending on how available data is. We pull it together. We have multiple reviews to make sure that we've all got a sanity check around the operational scenario and the data used and any assumptions made. And then we document it. And that documentation is really important for us because it partly allows us a means to be able to communicate to our customers, but it also allows us now to start defining those design for sustainability rules so that we can embed within new product development and right from the get-go design in reduced impact. So I'm really cognizant of time and that we really want to have a discussion. But if we look at the types of technologies and the areas that they could benefit, we put them in these 5 categories or buckets, if you like. So the first one is addressing these fugitive emissions, if you like. So an example there would be something like a low emission valve. We can look at reducing or eliminating flaring. So options around deep transient testing, for example, to prevent needing to flow to surface, building in zero flare facilities, or where flaring is needed, making sure that it is the most effective that it can be in reducing methane percentages. We can look at minimizing the drilling footprint, so rig emissions, either in time or in intensity of energy needed, through the equipment that is used both downhole and at surface, which includes also waste management and mud fluid processing. We can look at a broader full field development. So we're looking at subsea equipment, electrification and efficiency of boosting, looking at fluids like highway for fracturing, artificial lift pumps and so on. And then the electrification, a big topic for today, you know, our subsea equipment, our surface actuators and electrification of equipment, so to enable renewable energy usage. So we have this broad range. They're all going through this quantification methodology so that we can say what kind of benefits they would bring when they're in usage. One of the examples is a multilateral subsea completion that we did. This one sat very much on the material side of quantification. So the infrastructure needed around the pipeline and the subsea gave us several thousand tons of CO2 equivalent reduction by designing, if you like, this multilateral completion. Another example, I mentioned it, is Aura, where, you know, for a single zone test, preventing fluid to surface and the need to flare or vent at surface, we're looking at several thousand tons, around 5,000 tons for that single zone test by using a deep transient fluid testing downhole. And the last example I have here is a design in of a zero flare. So over the 10 wells over 1 year, by putting in a series of multi-phase pumps and feedback loops and a separator, we managed to prevent around 80,000 tons of CO2e that would have previously have been flared. I think one thing that hopefully maybe we can get onto in the discussion as well is I'm very focused on the technology design and the choice that we use for the activities that we do. But there are other areas around the operations optimization, and then from there, the planning and design. You know, Steve alluded to it as well. Right from the get-go, if we have a conversation about what it is to achieve and how we can plan and design in a reduced footprint from the get-go, then I think our opportunities are greater for reducing footprint. So that being said, I know it's a bit of a speed run, but I look forward to the discussion now.
Karen, that was great. Thank you very much, and thank you for speeding through it. So we've got some
I did
time.
15 minutes, I think, in the end, but yeah.
Yeah, no, that's really good, and hopefully we can get the other panelists back on videos. Yeah. So yeah, excellent. So we've got questions coming in. I'll start running through those in a moment. But firstly, a question from me, and I'll direct it at Karen actually, but Steve and Pierre may want to come in afterwards. So the question is around data, which is and measuring, which is the sort of bedrock of what we do as engineers and geoscientists. How do I know that Steve's 6 kilograms of CO2 per barrel is the same as Pierre's? How do we go about measuring one company versus another, one technology versus another, and even sort of company to company, country to country?
I would say that is actually a massive problem that the industry has. And we don't. There are different methods for calculating intensity per barrel. For example, there are different data sets for calculating, you know, various emissions factors and so on. And it's part of the problem that we have are these different data sets and these different standards. And I can only say my first say would be the transparency of scope and the transparency of method and the transparency of data used is our primary way of dealing with that today, whilst we don't have a single industry standard for doing this, if you like. Steve, Pierre, I'd love to hear your thoughts.
I guess, yeah, I mean, I guess it's, I think, you know, it seems to me, although it's not necessarily my area of specialty, but that some of these standards are being developed. You know, I guess, yeah, I mean, the difficulties is probably where you don't have the direct measurement. and where you need to rely on some form of either a calculation or some assumptions to calculate that intensity. Yeah, I mean it's certainly an area that is attracting a lot of attention and focus, just because, well, probably reason that we've just mentioned is essentially you want the intensity of Steve to be comparable to mine, and you want these numbers to be generated using the same principles and assumptions. So very fair challenge.
I mean, what I would say is I've learned a lot in the past year. So, I used to just get an environmental statement out, add up the CO2 emissions, divide by the number of barrels. I mean, it gives you a rough figure. It's not a bad way to do it. But those numbers are calculated for a slightly different purpose. And actually, you need to concentrate on it, and you need to put smart engineers who know what they're doing to work the numbers out. It's a lot different as well whenever you're looking at my numbers, which are projections of what we expect to happen that are based on process simulations and estimates of power demands and so on and so forth, versus an actual operating installation where, if you're keeping track of the methane, and that gets consumed in operations, chances are it ends up as CO2. So, you have a number of ways of cross-checking things. But I'm sure I will learn more in the next year but maybe not quite as much as I've learned in the past year.
Okay, thanks everyone. I think there's Pierre. I think the next question's directed towards you. We've had, I'll combine one from Jack Dunlop and Sean Gibson, both around the CO2. And Sean asks, will Neptune consider using any captured CO2 for enhanced oil recovery purposes? And associated with that, Jack asks, how do you propose to protect the integrity of repurposed oil and gas infrastructure in handling wet CO2?
Yeah, no, thanks. So, I mean, I guess I would say the answer is probably in the question, in the sense that you would want your CO2 to be as dry as possible, to be compatible with repurposing of existing equipment that have not necessarily been designed for sort of wet CO2. So I guess it's really in sort of making sure you have the right quality of CO2 to start with. As far as sort of CO2 for enhanced oil recovery purposes, I would say, well, it's not excluded. Obviously it's less obvious as a method to capture CO2, because you most of the time end up recycling sort of CO2. However, you have a certain fraction of the CO2 that is permanently captured. And it's an interesting idea, especially in countries where maybe there is currently no CO2 tax or no CO2 pricing, and where it's probably more difficult to find an economic justification to do something with our CO2. I mean, we usually talk about CCUS and the U being for utilization, but actually it's quite difficult to have an economic utilization of CO2, especially in some countries where you might be far away from markets for whatever products you might generate from your CO2. And also you very often need hydrogen to actually make something useful from your CO2, which adds up to the cost, etc. So yeah, so you are not excluded.
Thanks, Pierre. So I think I'll direct the next question at Steve. I mean, we sort of mentioned earlier how with a clean slate for a new development, it's easier to design in low carbon emissions. But we've got a question from Daniel Rogers, which is around the capital costs of doing the pilot development. And it's asking, how do you foresee raising enough capital for such a development? And I think it's a very good question around the sort of license to go out and do stuff and the willingness of the financial community to invest.
Yeah, I mean, it's a very pertinent question. I would say the capital cost for pilot won't actually be astronomical. It's roughly $1 billion to get to first oil, which is a pretty big number, but about 600 of that is the FPSO. So if we can lease an FPSO, then actually the remaining capital, and we're also planning to lease the wind turbine, and that's kind of smart because the cost of capital for a wind company is a lot lower than the cost of capital for a small oil and gas company. Maybe not for Shell, but for a small oil and gas company, that's certainly true. And we're left with about $360 million to find. There's still an RBL market. You can still raise money and reserve-based lending. And there's always a Norwegian bond if you're short of a drop of money in terms of putting some debt into the project. And the pilot field's got proven reserves of 58 million barrels, so you would be able to put some debt into it. But there's always going to be an equity requirement, and there's really two sources for us for that equity requirement. One is an oil company partner that wants to come into the best, most interesting project in the North Sea, just mentioning that in case anyone hadn't noticed. And the alternative is actually raising money in the market. And you know, not to beat about the bush, you can always raise money in the market. It's just the price that you're raising it at you might not like. So we're confident we can get the project going. We'll obviously be looking for the deal that provides the best value to shareholders. There's a good reason I'm doing that.
And would it be fair to say that sort of it's easier to take a low emission pilot field development to market than the original planned?
Oh, absolutely. You know, I think I wouldn't say that financiers are terribly moral people, right? So, but they do like to make sure that they're getting someone else's money to manage, and a lot of people are saying, I want to be compliant with ESG goals. So, you know, they'll definitely look much more favorably on a low emissions development versus a high emissions development. But, you know, the world needs oil and gas as we go through a transition. I think the IEA's forecast that we don't need new oil and gas projects is deeply flawed. It's based on an assumption that we can triple GDP and reduce energy consumption, not oil consumption, energy consumption. To me, that's nonsense. The Saudi oil minister called it a sequel to La La Land. These are all good lines. We still need some oil and gas through this transition. We still need some new projects. Let's do the best projects. Okay,
so we need oil and gas. We've got, you know, we've talked about the relative ease of addressing carbon emissions with a green field development, but most of the production today is from existing relatively mature fields. So probably a question to Pierre and Karen. Maybe Karen can go first, and it's from Alison Isherwood. So it's around, you know, what do we do with these mature assets? What are the low-hanging fruit, and what do we ultimately need to do to really drive the emissions down from these mature assets?
Many things, I would say. And if you look at that sort of spread that I showed you from the methane and fugitive emissions all the way through to the energy used in production facilities, this is where you could switch out one technology for another within existing plants and facilities in order to reduce energy consumption and emissions. Now, what will that technology need be will very much depend on the facility, very much depend on the fluid. Are we doing water processing? Have we got a gas cut? Whatever it happens to be, the equipment will be different, right? But there will be opportunities, and it's a case of looking at where those big pieces are for the process that you have, and then looking at what your alternatives are and switching out those alternatives.
Okay, and Pierre, is there anything specific you've found on Neptune's fields which make the big difference?
I guess probably similar to what Karen was saying. It's also small concepts. It depends on the specific issues you have in your different fields. But I would say that you need a long remaining life to be able to justify investments associated with decarbonization or emission reduction, more generally. And I guess often in the more mature assets, it's quite a challenge because you're already sort of significantly advanced, and by the time you kind of do all the engineering and construction, etc., it takes another few years. And once again, that reduces the useful life of your investment. That's probably where I'm thinking of repurposing and extending the life of the asset, which could be through there are different ways to extend the life of an asset, and it's not all about repurposing. I guess there is traditional oil and gas things that you can do to extend the life of your asset, and that should help your sort of making it work from an economic perspective, which is really an important element. So yeah, but I think like Karen said, there's a lot of technologies out there that should be considered, from capturing your emissions to and to obviously electrification we've talked about, but fuel switching might be something of interest for the future as well. So yeah, and technology is progressing, and everybody is trying to find the right solution as well. So just have to keep going.
Okay. And I guess a slightly associated question is really, we talked about electrification, and Steve talked about local electrification using a wind turbine, and Pierre, you talked about electrification from shore. Maybe what are the pros and cons? Do you want to take that one first, Steve?
Yeah, I mean, I've spent quite a lot of time sitting in OGA facilitated CNS electrification meetings and listening to what people are trying to do. I actually come at it from a slightly different angle, which is we're trying to reduce CO2 emissions on the grid, and the more baseload demand you put into a grid, the tougher that becomes. Because when the wind doesn't blow, really the UK is relying on all its interconnectors working, and all the gas plants firing up, and even sometimes a coal plant firing up, and Dinnerwig pump storage pumping out all the electricity it can, and your flexibility to cope with what you do when the wind's not blowing is putting quite a strain on the grid. And I'm unconvinced that actually power from shore is the answer for the Central North Sea. Having gone through the work we did on a local supply for our local project with our own backup systems in place, and that includes putting drilling a storage well in a little gas cap so that we always have enough gas on hand, and somewhere to put gas when the wind is blowing. I think those solutions are a bit easier to design and implement and get going quickly than the massive power from shore scheme. So
Pierre?
At the last CNSE meeting, I just threw a rock in the pool, which was, you've missed this concept, and this is a concept you should be looking at. So I'm probably the least popular person in the CNSE group, but you know.
Pierre, you know, Neptune have gone for power from shore. So do you want to say something about why you went with that route?
Well, if you're in Norway, that's what you should do.
Thank you. Yes, that's the answer. No, but I guess in Norway it works very well, but the conditions are different, and you have a very large supply of green electricity in Norway, so that is really a very unique set of circumstances. I mean, I suppose if you move away from the central North Sea to the southern North Sea, you have sort of fixed bottom turbines that are probably less expensive than floating ones, and that can be a solution. However, there is, like Steve mentioned, the issue of intermittency, and what do you do when the wind is not blowing? And from that perspective, being connected to the grid might help. Although maybe not, because I guess if everybody is relying on the wind, then the day is not blowing, it's not blowing.
Okay, thanks, Pierre. I'm very conscious we're running out of time. If it's okay with the 4 panelists, I might allow it to run on 5 minutes because we started slightly late. So just sort of probably the last question before we wrap up, and it's a slight change of tack, and it's a question from Promise Ahante. Around carbon pricing, we've largely concentrated on the technology, but some of the things which drive what we do from a development and a technology perspective can be driven by the tax situation. So he's asking around, should we have that for individual countries, or should it be setting it on a more global basis? Do you think it's better over the other? Is one better than the other? Do you forecast that individual countries who are more serious about carbon pricing would just get on with establishing their own tax? There's sort of do we have a volunteer to take that one first, the role of tax? Pierre?
I can try. I mean, I suppose it makes a big difference to have visibility and clarity on the sort of the outlook on CO2 price or tax, and that allows for investments to be made. In countries where you don't have that visibility, it's a lot more difficult, I guess, to really justify these investments. And the other point I would make is, obviously that potentially penalizes the countries that introduce these taxes, and then you have to compete with other sources of hydrocarbon from countries where these taxes are not present. So hence the discussions around carbon border adjustment mechanisms, for example, how unpopular this might be. So not an easy question, but CO2 is traveling, and it doesn't stop at anybody's border.
Yes. Karen, anything to add to that?
Not really. It's massively complicated, as Pierre said, between countries and supply, but that we're all influenced by the greenhouse gas. And we've seen many discussions on both sides, for and against. We're still looking at how to factor it in, if you like, from a product development perspective. Just the same way you would look at markets and revenue that you get from a technology. What would it mean from a carbon perspective too, and building that in? It's a bit like the standard for quantification. I think it's extremely early days.
Okay, thanks, Karen. Steve, anything to add to that?
I mean, it's clearly an incredibly difficult question. Just looking at it from the developer's viewpoint and looking at how we thought about carbon taxes, Actually, I took them out of the equation when we looked at it. Then I put them back in again because I wanted to understand the impact. But what was kind of interesting, and I forgot to say this in my presentation, was what it actually cost us to make all those improvements. And the answer is it cost us virtually nothing because we were able to eliminate a gas import pipeline and eliminate the purchase of gas. And the total incremental cost over the life of the field was $19 million to eliminate 1 million tons of CO2. When I do a calculation of 30 pounds per ton or whatever, obviously it's worth spending that money, but it's actually worth spending that money anyway, because it gives us more flexibility. We're more independent. I would do all this stuff anyway because we were able to eliminate other costs. And that's the great advantage of being at the concept selection phase. That's the most fun part of an oil and gas development, the concept select phase. Right. And making that choice, we've been able to do something that's, I say it's policy robust. It doesn't matter what the policies are. It was a good idea to do.
Oh, that's quite a nice point to end on, really, in that you can drive down emissions whilst also looking after the economics of your field. Yeah. And that if we can all do that, that's fantastic. Okay, so we're pretty much out of time. I think I'd just like to sort of do a quick round the table, closing comments, 30 seconds, a minute. We probably go in the reverse order to what you spoke. So Karen, then Steve, then Pierre, if that's okay, just your takeaways from this or any summary points.
Oh, right, excellent, on the spot. So, I mean, firstly, I think that we're having this conversation, right? And I don't think 2 years ago we'd have been having this conversation, right? What can we do to decarbonize oil and gas? What is meaningful? What can the industry do in building that momentum? There are some big options, we've talked about them, electrification, etc. But there are many, many options that are going to be needed across the E&P cycle. And it's across the value chain as well. No one person can do this independently. And so I think it's building that momentum, having the conversations, collaborating on it in order to both decarbonize and, like you said, make the economics work. Massive opportunity.
Great, thanks, Karen. Steve?
Yeah, so some closing thoughts. My perspective is from the perspective of a very small oil company that has limited impact on the world, as it were. One of the things I'm really struck by is how an effective regulator, being absolutely clear about what they want, can get what they want. So, when I was in BP and the Department of Energy wanted something, we'd always think about how we could stop them wanting that. When you're a small company and the Oil and Gas Authority turn to you and say, that's a very nice document, it's a very nice plan, but we want you to reduce your emissions. They said jump and we said how high, So I think the Oil and Gas Authority has actually been a very effective regulator, certainly in terms of what the impact it's had on us and the impact on our development. And it'll be regulators all around the world that will make this stuff actually happen.
Thanks, Steve. Thanks, that's great. And Pierre?
Yeah, well, I guess there's been a lot of good discussions this evening, and I would say that it's important to bear in mind that we will need oil and gas in the coming years, and 10, 15, 20, 30 years, and we just have to be sensible about it and really sort of not be too rash or rapid in sort of making decisions that would negatively impact what we have been doing very well in the North Sea for a number of years. There's plenty of opportunities, and I guess the energy transition is just creating new different kinds of opportunities.
Yeah, that's a nice point, Pierre. Thank you. And I think from my perspective, one thing I've really taken away from this is there are things we can do to drive down the carbon intensity of the oil we produce. And I suspect a lot of people on the call are wondering, how can I contribute to the energy transition? And given the core skills that you have in oil and gas, just look at your own company, look at what you do, and just have that mindset. What can I do on a day-to-day basis to help drive down the emissions and the carbon intensity? So I think that's it. I would like to bring back Alison Isherwood, if she's there, to sort of do any further closing remarks. Any thoughts, Alison, as the chair of our Net Zero Committee?
Yeah, thanks, Barney, and everyone. That was great. We could talk about these things for much longer, but I think we always want people wanting more. I loved the different perspectives that we got. That's what we try and do on these panels, bring different perspectives. But I was struck by the ambition from all of you at different levels, Karen with Schlumbergers, to a big global company trying to really get their arms around sustainability as a whole and looking at their technologies. And down to Steve, as you say, as a small company, the journey you've been on to understand all of this, and we're all on a learning curve. But the I learned some things from your project. Thinking about the reservoir management of a project and doing it quicker and more efficiently can reduce emissions as well. So loved all the different perspectives. So in terms of our forward program, I think you touched on a few things that we're hoping to cover in more detail. So the financing of this and the economics, we call it the carbon economy, is what we're going to tackle in October, on the 14th of October. Looking at the carbon pricing, etc., impact on oil and gas projects, new energy projects, and comparing it to nature-based solutions as something a bit different there. So we're working on that as our next thing. Then, of course, we've got COP26 coming up. So I'm working with Aberdeen to have another panel discussion probably after that, towards the end of November, to really focus on policy and regulation. So that was something else that came up here on the back of COP26. SPE International are also doing a couple of COP26 events leading up to it. So I'll make sure that SPE London and myself, I'll be sharing those. They are open to all. And also I'll be continuing to work with SPE International on just transition topic and skills, which is something we transferable skills and careers in new energy that we'll continue to investigate with SPE International in a whole series of events. So thank you everyone, our audience, for joining us. I hope you enjoyed it, and we'll continue to try and bring you interesting discussion. And thanks again to our speakers. That's really good.